Hey there. Today we're going to be looking at graphing quadratics in Vertex form. So once we get to the graphing part, it's very much like how we did things in standard form. And so a lot of that part stays the same. It's just how we start the problem that's different. We do not need to use x equals negative b over 2a. We will not be doing that this time around. Instead, vertex form gets its name because if you look carefully at the equation, it gives you the vertex. So vertex form looks something like this. A, h, and k are just numbers. If you don't see a number in front of the parentheses here, that means a is 1. Usually we'll see both a number here for h and a number here for k. The h and the k give you how to find your vertex. To find our vertex, when we're in vertex form, we change the sign of whatever the h number is, and that becomes the x coordinate of our vertex. We keep the k number the same, and that becomes the y coordinate of our vertex. So I'll just do a couple of quick examples for you for finding the vertex. So for instance, if I had this equation right here, if I change this sign, that 3 becomes negative 3. If I keep this the same, that negative 1 stays a negative 1. So my vertex would be negative 3, negative 1. I didn't have to do any work to find that, I just looked at my equation. I'll do another quick example. Here, if I change the sign of this, positive 2 would become negative 2. That'll be the x coordinate of my vertex. I'm going to keep this the same. That'll be the y coordinate of my vertex. So my y coordinate is 3. So the vertex of that equation would be negative 2, 3. It's pretty slick because we don't have to do a lot of work to find our vertex. We just see by just looking at the equation, making a little adjustment. So the steps we're going to take for these is we are going to start by finding our vertex by looking at our equation and then plot that point on our graph. From there, I'll go ahead and have you draw on the axis of symmetry, which will help you reflect at the end. After that, you're going to choose 2 more points to plug in and plot those on your graph. And hi, my dogs are visiting, so I wasn't expecting that. Hopefully they'll be nice and quiet for us. And so you're going to choose 2 more points to plug in for x and plot them just like we did in standard form. You'll use your axis of symmetry to reflect, and then we'll connect. Sounds like a lot, but it's stuff we've done before, other than we're just changing the beginning part. Let's dive right into our first example. So here's my first equation, y equals negative x minus 1 all squared minus 2. I'm going to start by finding my vertex. I'm going to write down here so I don't run into my graph. My vertex, if I look at my equation, I'm going to change the sign of the number in the h spot, so negative 1 becomes positive 1. I'm going to keep the negative 2 the same. It's the y coordinate of my vertex. So my vertex is at 1, negative 2. I'm going to go ahead and graph that. X is positive 1, y is negative 2. That goes right here. From here, I'm going to go ahead and draw my axis of symmetry in. Remember, that's the imaginary vertical line that goes through my vertex. We'll get back to that in a second when we go to reflect. Just like we did with standard form, we're going to choose 2 other numbers to plug in for x to find 2 more points on our graph. It'd be nice if those numbers were close to the x coordinate of our vertex. So since the x coordinate of our vertex is 1, we're going to pick 2 other numbers to plug in for x. I'm going to choose, I'm looking at my number line here, numbers that are close to 1 would be 0 and negative 1. Actually, let me write that a different way because that kind of looks like an ordered pair. Choose x equals 0 and x equals negative 1. When I do that, I just plug those into my original equation. So negative parentheses 0 instead of x, minus 1 squared minus 2. I would recommend typing that all into a calculator at once, but you can do things by hand as well. 0 minus 1 is negative 1 squared. Negative 1 times negative 1 is positive 1, but then this negative makes it a negative. Minus 2, negative 1 minus 2 gives me negative 3. So that means one of the points on my graph is the x I plugged in, which was 0, the y I got as a result, which was -3. Let's go ahead and graph that. X is 0 means we're going to be on the x-axis. Y is -3 is right here. Now I'm going to do the same process but plug in -1. So -1 is just going in here. -1 minus 1 is -2. -2 times -2 is 4, but then we have a negative in front. -4 minus 2 gives me -6. Again, you don't need to do that by hand. You can use a calculator. I would highly recommend that. So anyway, the point we ended up with was the x-coordinate I plugged in is -1. The y-coordinate I got was -6. To graph that, x is -1 is here, y is -6 is down here. We've done a lot of the hard work. On your homework and on future quizzes, I'll be asking you to give me 3 points that are on your graph. So you'll just list 3 ordered pairs. You could have also chosen different x values. You could have chosen 2 and 3. That would work lovely. Whatever makes sense for your brain. From here, to make the rest of my graph, I'm going to reflect over my axis of symmetry to get 2 more points. This green point is 1 away from my axis of symmetry. Go 1 away in the other direction, that gives me 2 -3. This green point is 2 away from my axis of symmetry. Go 2 away in the other direction, and I get 3 -6. Once you have all 5 points, connect them with a parabola like that. So again, on your homework, you're just going to list the 3 points that we came up with. That'll be one question. Another question will be, choose which graph matches this equation. You won't be graphing yourself. You'll be finding the graph that matches what you want. Let's do one more. So, let's start the same way. Let's start by finding our vertex. Our vertex for this problem, remember we changed the sign of this number, so -4 becomes +4. We keep this the same, so my y-coordinate is going to stay -2. Let's go ahead and graph that. X is 4, y is -2. That's going to be right about there. And then let's go ahead and draw in our axis of symmetry carefully. Like that. It's just the vertical line that goes through our vertex. The x-coordinate of our vertex is 4. So we're going to pick 2 other points to plug in that are close to 4. You could go 3 and 2. You could go 5 and 6. I'm going to go 5 and 6 just because I haven't really done any to the right yet. So I'm going to choose x equals 5, x equals 6 to plug in. When I plug them in, they're just going in the x part of my equation. I'm going to start with 5. And you are welcome to type all this in a calculator. I'm going to walk through the math. 5 minus 4 is 1. 1 squared is 1. 2 times 1 is 2. 2 minus 2 gives me 0. So after all that work, we end up with, when I plug in 5, I get 0. So the ordered pair 5, 0. Let's go ahead and put 5, 0 on our graph. So x is 5, y is 0, goes right here. Now let's do the same thing but plug in 6. So now 6 goes in for x. So 2 parentheses 6 minus 4 squared minus 2. You are welcome to type this all into a calculator like Desmos. I'll walk you through the work. 6 minus 4 is 2. 2 squared, or 2 times 2 is 4. 2 times 4 is 8. 8 minus 2 gives me 6. So once you've plugged in 6, you also get 6. So my ordered pair is 6, 6. Going to graph that. X equals 6 is here. Y equals 6 is up near the top. We need 2 more points to make this into a proper U shape. Use your axis of symmetry to help you reflect. This point is 1 away from my axis of symmetry. Go 1 away in the other direction. Marker's not cooperating, give me a second there. same thing here. This point is 2 away from my axis of symmetry. Go 2 away in the other direction. That gives me the point 2, 6. Once you have all 5 points, connect with a parabola. Now you should feel a little bit more comfortable with graphing quadratics in vertex form. I hope you have a great day.